Hello, today we're going to be talking about vector addition. So in many cases, we're going to need to find the total or the net force acting on a body. This also can go for things like velocity and acceleration. And when we're finding the net force on a body, that's going to be the sum of the force vectors acting on the body. So since forces are vectors, not scalar values like mass, we can't simply add up the magnitudes. We're going to need to take those directions into account as well. So geometrically, what we do when we add vectors, if we've got, say, two vectors, we've got F1 and F2, we're going to put those two vectors what's called tip to tail. So when we move vector 2 up, so the base of the vector is up here, and that'll move the tip somewhere up there, like so. And then we're going to go from the base of the first vector to the tip of the last vector. And so we just build up a longer and longer chain to add up more and more vectors. So our overall total vector, the addition of the two, is going to be this vector going from the base here all the way out to the end. It's going to be a straight line connecting those two. So you can see geometrically we've got a triangle. It's not a right triangle, so I'd have to use law of sines, law of cosines to find that total magnitude. And finding the direction would also be a bit difficult, but there's an easy way to actually add these things together. So the easiest way is going to be to break everything down into components. So I've got my force 1 and force 2, and I break force 1 into x and y components, force 2 into x and y components, and the addition of the two vectors, I can use these components to easily add them together. So add the components in each direction, and that means that in the x direction, the x component of force 1 plus the x component of force 2 will give me the x component of the sum vector. And the y component of F1 plus the y component of F2 will give me the y component of the sum vector. This works because all of the x components, all of the y components, they share kind of a common direction. They're all going in the x direction, or for y components, they're all going in the y direction. So we simply add up the components to find the overall components of our sum vector. And if we need to in the end, once we have the x and y components of my sum, I can go and convert back to a magnitude and direction, as I talked about on the vectors page, to kind of go back to that. So with that, that's all I have for vector addition. Thank you for watching, and I hope to see you again.